So don't treat me like dirt. Don't treat me. Don't treat me. Don't treat me like dirt. But you know what I'm gonna do? Somewhere
subject for tonight's lecture is rhythm. The beat. The driving force that holds our lives together. Without rhythm, your heart wouldn't beat. Without direction, without moods, and without shadings. And so tonight we say, hip hip, chin chin, the rhythm section. And so tonight we say, hip hip, chin chin, 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 hip hip, chin chin.
Still old-fashioned.
The subject for tonight's lecture is rhythm. The beat. The driving force that holds our lives together. And so tonight we say, hip hip, chin chin, hip hip, chin chin, hip hip, chin chin. Hip hip, chin chin, hip hip, chin chin, hip hip, chin chin, hip hip, chin chin, hip hip, chin chin.
I will see the presentation here at the same time.
Hello, darkness, my old friend. I've come to talk with you again. Because a vision softly creeping left its seats while I was sleeping. And the vision that was planted in my brain still remains within the sound of silence. In restless dreams I walk alone, narrow streets of cobblestone. Neath the halo of a street lamp, I turn my collar to the cold and damp. When my eyes were stared by the flash of a neon light, split the night and touch the sound of silence. And in the naked light I saw 10,000 people, maybe more. People talking without speaking, people hearing without listening, people writing songs that voices never shared, and no one dared to steer the sound of silence. Fool, said I, you do not know. Silence like a cancer grows. Hear my word and I might teach you. Take my house and I might reach you. But my words, like silent raindrops, fell and echoed in the wells of silence. And the people bow and pray to the neon god they've made. And the sun flashed its warning in the words that it was forming. And the sign said the words of the prophets are written on the subway walls and tenement poles, and whispered the sounds of silence.
Someone call a doctor, I require water. Now the music's over, I'm feeling under pressure. Oh yeah, oh yeah, oh yeah, oh yeah. All night long we're grooving, tunes them got us moving. People smiling, smiling, living on a good feeling. Turn on the bright white light. Oh yeah. 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 Now that the music's over, oh yeah. Turn on the bright white light. Oh yeah. And now that the music's over, oh yeah. Turn on the bright white light. Oh yeah. Lover, I surrender to this music fever. Always smiling, smiling, leaving on a good feeling. Spin, stop, push it louder, let it play forever. People smiling, smiling, leaving on a good feeling. Oh yeah.
Oh.
Oh yeah. Oh yeah. Oh yeah. Oh yeah. Good feeling. And now that the music's
Hapa ni video game lagi load. Baca aku biar
turn on the bright white light. And now that the music's over, turn on the bright white light.
you know sometimes you go off. One just
Hello? Can you hear me? Okay. Perfect. Hi, everyone. How are you today? Welcome to the session on sustainability and technologies in international cooperation, a very complex relationship that could be a happy marriage or a conflictual relationship. We look forward to your active participation over the coming 2 hours from all of you here in the room, as well as our online participants. My name is Chachila Gutu. I am a PhD student at the Energy and Technology Policy Group at the ETH of Zurich, and today I'm here representing the ETH for Development Initiative, and we are partnering with the EPFL Essential Tech to host this session. If you're interested to find out more about what we do, you can take a look at some of the stalls and the stands outside right next to the registration desk. So we're hosting the session with Soli, who will also introduce himself now.
Yes. Good morning, everyone, and a warm welcome. We're very happy that you could take the time to actually come and listen to the session. My name is Soli Makotliso. I'm the Deputy Director of the Essential Tech Center at EPFL in Lausanne. So we, I would like to extend our gratitude to both ETH4D and the Essential Tech Center, who are responsible for organizing this session for you this morning.
Right. So our session intends to look at technology and the role that it can play in aligning climate action with international cooperation. And so we have 3 objectives in this session. We want to explore the interaction between international cooperation and aligning it with climate action, and more specifically looking at how technology fits into this discussion. We want to identify some key aspects of this conversation on technology's role that need to be addressed. And then finally, we want to understand what the focus of the different actors should be. And so we've scheduled 2 hours for this session. For the first hour, we'll listen to pitches by entrepreneurs who are doing some work in this space, and you, the audience, here physically as well as online, will be able to engage with them on some questions. Kindly use our very good friend Slido to pose your questions, and then we'll relay the questions to the people who will pitch. Then after about 55 minutes, we'll then have a panel discussions with some of the entrepreneurs, as well as experts who are working in this space to share some more in-depth insights. And so now I'll hand over to Soli, who will welcome the ambassador to start the session.
Yes. We are very privileged and honored to have Ambassador Manuel Bessler to actually give us a warm welcome word of this morning. And Ambassador Manuel is the Deputy Director General of the Swiss Agency for Development and Cooperation. He is also the head of the humanitarian aid. He's the head of the Swiss humanitarian aid and a delegate for humanitarian aid. So without further ado, I hand over to Ambassador Bessler.
Thank you very much. Thank you. Good morning also from my side, Churchill, Soli. Great to have you here. Welcome to also to this session 7, and particularly the colleagues and friends, ladies and gentlemen online. Yes, let's do some marriage counseling here. Is this a happy marriage? Look, I work now since a long time, not revealing my age, in humanitarian affairs, and it's a forced marriage. Without technology, we would be nowhere with humanitarian aid. Just look at the global humanitarian overview that was published in January before we had the disaster in Ukraine. An appeal launched by the UN, only UN, not Red Cross, Red Crescent, NGOs. We have 274 million people that are in need of humanitarian affairs. That's more than the population of Pakistan. This appeal or this overview looks for 41 billion US dollars to address the needs out of these 274, 180 million people. The trends are going in the wrong direction. We have more than 1 person of today's population in the world that are displaced. These are something like 80 million people that are on the move. And being displaced, that means you're vulnerable. 80 million people, that's the population of Germany. And you heard it yesterday in the general debate. By 2015, 216 people will be on the move because they cannot live anymore where they live now, right now. Because, yes, of climate change, but also because of conflict, because of pandemic. So we look at huge challenges, and of course, for this we need technology and we need a sustainability. Therefore, the question is a more rhetoric one. Now, how to address it. And there I look very much forward to these different pitches. We need innovation. We need thinking out of the famous box. We need some new ideas to get us going. The humanitarian mandate is rather simple in terms of defining it, saving lives and addressing human suffering. And for this, of course, it can and has to be done in an adapted way, but also in a way that does take care of the environment. Think of the Rohingya crisis, 2017. Within a couple of weeks, 700,000 people were displaced and had to find a new shelter. They came to this area of Cox's Bazar in the south of Bangladesh, where there were already Rohingya refugees from ages and sometimes generations before. And suddenly this smaller camp became one of the biggest camp in the world. The environmental impact of this displacement. A whole city moves in terms of what they need as space, what they need water, what they produce in terms of waste, in terms of any other impact. Obviously, there to address these challenges, it's needed to have technology on board, to have innovation on board, and to think way beyond that. In previous days, humanitarian aid, development aid was done. We look at these famous 3 C's these days: conflict, and you don't have to look far from here. We address climate change, and this we see actually here. And yes, COVID, perhaps we have to put it more general, pandemics. These 3 C's can only be addressed together. And they have severe humanitarian implications. Food shortages. We will address a major food shortage in the Horn of Africa. Yemen, Central Africa will be will be affected. And again, we speak about, never seen since decades what we're gonna face with all the other crises we have to address. These consequences, of course, have an impact on social behavior, of course, have an impact on social turmoil, can even provoke new armed conflicts. So it's sort of a vicious circle. Swiss Humanitarian Aid, where I'm working, tries to address this, among others, with this technical, Geneva Technical Hub. Have a look, it's also here in the exposition. This is a joint venture together with HCR, together with the EPLF, or FL, the Swiss Federal Institute of Technology, based here in Lausanne, to address sustainable energy. People on the move, people in need energy. How do we provide this energy? We look at safe and ecological construction. How do we build, and with what kind of material, shelter? Where will you take this material? You should see it in Cox's Bazar, around the camp. Every little forest, every little woods are cut down. In this cooperation with the Geneva Technical Hub, we look at camp planning in general. How a camp has to be set up before we start to pitch up the first tent. We look at reducing the ecological damage in and around the camp. Waste management, as I mentioned before, is a major issue. Drinking water, of course, and in general, the reduction of risks. The goal is to become greener, carbon neutral, also in humanitarian action. Of course, when you look at the needs of people on the move, perhaps it's not your first thought, but there we have to think already beyond the immediate address of the needs, and to have also this in mind. We are convinced technology and social innovation can make indeed a big contribution also to this humanitarian mandate. And we have to be clever, we have to learn, we have to constantly involve with what's new, with institutions, with brains and networks that help us to keep us going. 15 years ago, Switzerland developed the first flood early warning systems, which was based on radio communication, using the satellite links as a backup channel. Our governmental partner, they, of course, were unable to maintain this system because the fees, the communication fees back then with the satellites were way too huge, and so it was not sustainable. Today we have different constellation in terms of satellite coverage and much cheaper data links for everybody. In this regard, we made a huge step forward. Technology has become an important part of early warning systems, and nowadays, in times of climate change, it's even more important than ever. We have recently supported GSM-based early warning systems, for instance, in Cambodia. People get their water level, or the water level of their river in their area, on their cell phone, and it rings an alarm when upstream the waters are rising. So this kind of early warning help. And this leads also that today we can say, and you see it also confirmed by OCHA, half of today's crises are somehow predictable. We cannot sort of hide anymore. No, I had no idea that this was coming. Of this half, 20% are actually highly predictable. Now, when you look at the financing, only 1% of the financing for these crises is prearranged. So we have this predictability, mainly thanks to technology, but on the resources side, we are nowhere. And obviously, there, anticipatory action can be, or has to be, a way to sort of make out of these limited financial resources the best effect, meaning getting more bang out of the buck. A specific role, I would like to mention hazard maps and specific hazard maps. Here in Switzerland, and actually if you have the time, it's worthwhile to get a bit in contact, and I'm sure there are also representatives here. We have a quite developed collection of hazard maps that we know if, I don't know, the snow melts, the water are rising, we know where are the areas that there will be water. We even know how far the water can come. And these kind of maps are today GIS based and give quite accurate prediction where are the hazards. So no, we are not anymore just surprised by the elements. We can see them coming, we know even where they are, and often in this regard it's wrong to speak about a natural disaster. It's not necessary in first line that the nature creates disaster. Actually, disaster is created by human beings in building, in area where you know that disaster will hit. All the more when you have these kind of maps. Look, we have to take into account, of course, in this kind of thinking, our local partners. We have to have eye to eye with our local partner, not sort of as an implementing partner, seeing them, but as a partner that are crucial for getting the right preparation before disaster strikes, and then having the right answer on the spot. Therefore, specifically, technology has to be linked with local knowledge, with local experience, with local partners. This link is somehow crucial. Otherwise, we miss major points and major sort of feedbacks, major information that are crucial to address disasters and the impact of disasters. I would like to sort of mention Switzerland wants to be a donor. Switzerland wants to be an actor, so we have our own activities, but Switzerland will also be an advocate. And when it comes to anticipatory action, when it comes to this marriage between technology and international cooperation, Switzerland sees it very much as its role to push this, to promote it, and to enable this kind of interaction. In this regard, I'm very happy and very curious to look at these different pitches that we're gonna get presented afterwards, and I would like to encourage you to use this, as it was put by the moderation here, as an interaction, and ask any question. There are no stupid questions. With the answers, I'm not always sure, but get involved here. That's what we try to have with this forum, and I wish us an interesting coming 2 hours. Thank you.
Thank you very much, Ambassador Bessler, for those inspiring words and call to action. It's actually music to my ears, especially coming from a technological innovation institution such as EPFL, and also to my colleagues, I'm sure, at the ETH in Zurich. We shall now proceed to the first part of this session, which consists of essentially 5 pitches. 3 of which are supposed to happen in person, and 2 of them will actually happen remotely. Each speaker will have a total of 10 minutes of which 8 should be the actual talk itself, and a few minutes, 2 minutes, for questions that you can please put on Slido. So this also refers, we are hoping also that our online participants will actually participate in this process. I also wanted to bring your attention that we have a knowledge wall where you can actually provide some reflections throughout or at the end of this session with regards to 3 points, basically what we can continue to do, what we need to change in how we do things, and what we should commence or start doing. And so there are also, sticky notes at the back there, and there is, I believe, a remote version of the, a virtual version of this knowledge wall as well. So I urge you to make use of it. I think it will help the organizers and all of us here to get everyone's feedback from multiple channels. So without further ado, I will now welcome the first speaker. And basically just one final point with regards to each of the talk. Most, if not all, of the speakers will start by posing a question that's related to what they are going to present. And this question will be in the form of a multiple choice. So you are actually encouraged to try and guess the answer via your Slido right at the beginning. And we will then see at the end of the talk what the correct answer and how many of them actually got it. So without spending too much time, I would like to welcome our first speaker, who is Freddie Nanju, and he will be speaking about an affordable solar fuel for clean cooking. So in other words, co-production of solar hydrogen and oxygen for clean cooking. Over to you, Freddie.
First of all, allow me to thank you for inviting me here and for giving me the opportunity to introduce myself and to present the approach and the solution in which we believe and that we are implementing now in an international cooperation between Switzerland and Cameroon. So I am Freddie Nanju. I am the founder of the startup SoftPower. That's the spin-off of the Laboratory of Renewable Energy Science and Engineering of EPFL. So please allow me to start my presentation with a few questions. Maybe you can. Oh. Is it okay? Okay. Perfect. Sorry. So, excuse me. Are you changing the slides or?
You can change it.
Because it seems like they are two different.
Which one do you want?
Yes, excuse me. Yes, there's a small mistake between the last version of the presentation I sent and this one that I have here. But anyway, the questions are the same. So let me start with a quick question. How many people in the world do you think rely on polluting fuels and technologies for cooking? A, 30 million. 2, 0.3 billion. And 3, 3 billion. Note that today we have around 7.7 billion people in the world. So you have 10 minutes to find the solution, and at the end of the presentation we could discuss about the right answer. Okay, so let me present our solution that we have here. Okay. So what we do, what we propose is a solution to solve the problem of polluting fuels that people use in many countries in the world for cooking. And what we propose is to use solar energy as an input, as you see a solar farm here, and water as the input. So water is the only feedstock that we have here, and solar energy is the only energy input. And what we produce as the output is oxygen and hydrogen. What's hydrogen? Hydrogen is, you know, that is a fuel. Yeah, hydrogen, you know, that is a fuel with a high quality. It's a fuel with a very, very high energy density that can be used in the fuel cell cars, for cooking, and also for heating applications. And oxygen is a product that is used in industry and also in medical health centers. If you take the example of the 2020 with the problem with the pandemic, we had a lot of lack of oxygen everywhere in the world, and mainly in developing countries, and millions of people died because of that. So what we do here is that we propose to use existing technologies, because when I say a revolutionary solution, I don't say revolutionary technology because the technologies already exist. We just use the synergy between different technologies and different applications to develop a system that is bankable. So what we do here, as you see, so we produce hydrogen and oxygen for solar energy and water, and use the hydrogen for clean cooking. As you can see here, we develop a hydrogen stove. This is the main innovation, technological innovation of our solution. A hydrogen stove that was developed at EPFL. And the oxygen, we use it, we supply it to health centers, so we could have a kind of local production of those renewable gases. So, next slide. Okay. So here I present our business model. Just for information, this is a business model that assumes that here we have a world that works with our solutions, that we have a mega or gigawatt scales, power plants that work with our solution. What are the targeted prices, the long-term targeted prices? So for that, we use the cost of hydrogen that we need to be competitive with the existing fuels that people use for cooking. And we use the cost of oxygen that we obtain from market surveys in sub-Saharan Africa, for example. So as you can see here, we use 50 kilowatt hour of solar energy and 9 liters of water. And with that, we estimate the cost of our processing system, that is photoelectrolysis. And we come up with oxygen with around 6.7 kilograms of oxygen and 1 kilogram of hydrogen. And then we have the transportation system in which we could use trucks or pipelines to transport the hydrogen, the oxygen to health centers, and the hydrogen to households that can use it for clean cooking. And one important aspect that I forgot to mention in the previous slide is that the only combustion product of our hydrogen stove is water. So the 9 liters of water that we use here in the power plant, when we use it cooking with hydrogen, we produce again 9 liters of water. So we have a circular economy. And the advantage is that this water is really pure water. It's just a combination of hydrogen and oxygen again. So our stove also works like a kind of on-site water generator that we have at home. And as regards the stove, as you can see here, we just use metal components and with some small catalyst material, not just activate the reaction, because we use a technology called catalytic combustion. We have no flame. We have a very limited temperature for combustion in order to avoid the production of any pollutant. And with our process, we have an assembly process where we put all the components together. And as a component, as I say, we just have just kind of foam. We have this ceramic foam. On the top of it, we have the platinum catalyst that we put on the mesh. And we also only have metals. And somewhere we can have glass ceramics, even if it's not adapted to all the context. Yeah, okay. And come out with this solution of the stove that we are targeting a price anyway lower than $100 for one stove of 4 kilowatt. So here I present the team that our global roadmap. So we started, today we have a power plant, a demonstrator. We have the stove that's ready. And we have the team here, is Soft Power. It's composed of myself and my collaborator, the co-founder, who is from Geneva. And we are collaborating with EPFL, that's led by Professor Sophia Hausner, and also the responsible engineer of the project, Mathieu Jonin. And today, so we started from scientific research in 2012, and now we are going to research industries. We have the first demonstration that is ready this year. Now we are working on fundraising alliances in order to have a pilot project, a megawatt scale project in which we can really demonstrate that the technology is bankable. And study the impact, and once we have the pilot project ready, we could repeat it everywhere in the world according to the needs. So with this, I thank you for the attention. So maybe before starting the question, I will answer to the.
So
survey.
maybe let's see the poll, slide of poll, quickly.
Wow, perfect. You can applaud for yourself. So,
Thank you.
Yes, so what you see is that, we have 3 billion people. So that means around 40% of the population in the world still use charcoal, wood, and very polluting fuel. When I mean polluting, I don't mean only polluting for the environment. It pollutes people because they breathe the combustion products of those fuels. And that generates a lot of death annually, more than 4 million deaths every year. And it's also really important to note that 40% of those deaths are children that are below 5 years old. Yep.
Okay. We have maybe just 1 minute for one question on Slido, if there are any. A Slido, okay. You've got one. There's one question here. How can the initial setup for the comprehensive solution be best financed to cover the upfront cost, especially in cities with lower power capacity or budgets?
Yes, for the finance, I think there are 2 aspects, to finance the power plants themselves, and also to finance the users who are supposed to buy the stoves and consume the clean fuels. So for the power plants, I think we need a very high investments, because this solution proposed works with economies of scale. So in order to be bankable, we really need societies that completely switch to these renewable gas economies and develop solutions that can allow to supply, I would say, 100,000 scales per people for a power plant. Yeah. And for the users, sometimes the capital expenditure, what they need to invest to buy a stove, to be the owners of the technology is very high. So I think there's also that aspect of the financial models for people who are supposed to buy them, and also solutions like allow them to use the stove, just rent them, and consume the clean fuels.
Well, thank you very much, Freddie. Unfortunately, we've run out of time for this talk, but there are still very interesting questions there on Slido. We will find a way to actually communicate them to Freddie, and maybe this discussion could be carried on offline. So on that note, we will now move to our second speaker.
Thank you very much.
Thank you. Thank you very much. We now would like to welcome our second speaker, who is Gabriella Crecchini. She will be speaking to us about technology for sustainable construction and affordable housing. And the title of the talk is Oxara Sustainable Construction. Welcome.
Thank you very much. Actually, it's the first time that I can represent Oxara in public. Oxara has been funded by Nanli Landru and Thibaut Desmoulins, and Nanli himself is actually from the Global South. He's Togolese, and he did his studies in EPFL and in his PhD in ETH, where he also refined the technology that he has been inventing. This is, but I start actually not with the technology. I would like to, next slide please. Okay, I'd like to start with the problem that Nanli wanted to address us from the beginning. Let's take the building constraints in focusing on housing, because to have a decent house or home is a human right, and it's the basic condition for a person's development, well-being, equality and inclusion. But the fact today is that 1.2 billion people are not living in decent housing, and of these 1.2 billion, even 135 million in Europe. So, and if you look at the future, in 2030, the World Bank estimates that this number will grow to 3 billion people. So how do we provide sustainable housing for 3 billion people in the future? Construction has its own constraints. Everybody has heard CO2 production from construction is estimated at 40% of the CO2 production worldwide, whereof 8% of man-made is only from cement. When we look at the Global South, most buildings are constructed nowadays with either cement or brick-fired and mortar construction. So both of these have their own constraints. And if you look at bricks, Freddie just mentioned it before, brick kilns, they need a lot of energy. Normally it would be done with gas. There has been a lot of initiatives also from International Development Corporation in Switzerland to improve brick production in the Global South. But still now most of the brick production is done in artisanal brick productions where they use woods, coal, and if not available, other not suitable firing materials as old tires and so on. So the problem goes much beyond CO2 actually in construction. All the air particulates and pollutions that come with it. For example, in Bangladesh, Dhaka is the fourth biggest producer of bricks actually, Bangladesh. And in Dhaka, it's estimated that 80% of the air pollution comes from brick production still. So we are facing a really big problem. So how can we build now these houses for 3 billion people without affecting the climate? So this is the leading question for the day, and this is what actually, next slide please, Oxara faced. So they said, coming out of Togo, earth construction is actually something that we could modernize. We can promote circular construction technologies by reusing construction wastes and make construction more people and climate friendly. So therefore they have invented additives that can be added to earth-based materials and can be then processed like normal cement or materials for brick production. The positive side is A, these additives are nature-based, so they are available in all countries where we are working. They are not affecting the environment, and they don't need to be fired. So they can construct now bricks only by drying them, like concrete bricks were done also in the Global South, that are not needed to be fired. So this comes to my question, and I had the leading question. We didn't show this. Oh, sorry, we forgot to show the question, so you will get it. So the question is, how much CO2 is produced by 1 cubic meter of cement in Africa? This was the question. I'll leave you some time. You can.
It's oscillating, yeah.
Yeah.
Okay, yeah. Maybe
Okay, thank you very much. Actually, I start actually with Europe. In Europe, 1 cubic meter of cement can be constructed with about 250 to 280 kilograms. This is because of our procedures that are very industrialized. In the Global South, I'm very sorry to say it's about 400 kilogram per cubic meter. So, I mean, and if we give an estimate, if we give somebody a person, we say per person we need a room size of 2 square meters and a wall of like 2 meters high on these 2 square meters, this would probably use about 1 cubic meter of cement, just this small space, and flooring. So, yes, and when I said, okay, 400 kilograms of CO2, for me, is this a lot? Is this little? How much is it? So I Googled and said, okay, how much CO2 is the sequestration potential of a grown tree? And actually, a grown tree has about 10 kilograms per year, which means that 1 cubic meter of cement in the Global South would need about 40 trees equivalent. So this gave me like a figure on what we're talking about. So, but what is now the potential of the Oxara materials? The Oxara materials, they end up actually, and we probably can have also the next slide, the Oxara materials end up at 90% saving, which means that the first number, this 20 kilo per cubic meter of cement, would be the result for an Oxara cleancrete, and it's about the same for bricks. So, yes, besides reducing CO2, the Oxara solutions, because it's not fired and it's not having this heavy chemical procedures, are also about 20% cheaper than conventional housing. So when we are coming back to is technology a constraint or a happy marriage, I think we do believe that it's a very happy marriage. Thank you very much.
Thank you, and thank you, Gabriela. And we were able to finish ahead of time, actually. So
normally I'm too fast.
so we have time for a few questions on Slido, if possible. Do you see any? Could you, yeah, if you could maybe show, yeah. Okay, first question. Which actors are needed to scale this technology?
Okay, as the production is only additive production, we need construction companies that are interested to change their behavior. So we heard behavior change is probably one of the biggest problems that we will be facing. Their production processes need to be changed and their behavior needs to be changed. But if you think of the global south, if you think of also resources besides clay-based materials that also cause their own problems in this huge scale, it's also that we can use construction recycled materials, so it will probably also need somebody that is able to recycle all construction materials. But that's about the two actors we need.
Okay, thank you. And the next question is the resistance of these bricks similar to normal concrete?
I mean, I cannot say whether it's similar to normal concrete because they are normally not used in the same way and not enforced in the same way. I can say the bricks are 100% the same, have the same strength as fire bricks, whereas in concrete, when we build in three-dimensional, we are not yet there. We cannot, we can build in 2 stories high, for example, but in Switzerland or in the global north, it's just for not structural constructions yet.
Mm-hmm. Okay, thank you. I think we have time for one last question. What kind of raw material is used? Is soil degradation accounted for?
I mean, this is what I just mentioned. Naturally, for so many people, if you use normal clay, this is another problem that we are facing if it's not restored, the places where the clay is taken from. This is actually not the first question that Oxara tried to solve, but I think in partnerships, especially in the global south, and there probably international cooperation could play a part in changing the behavior and also restore regions.
Thank you very much, Gabriela.
Thank you very much.
So now our next 2 speakers will actually intervene, will actually come in remotely, will speak from afar. So the next speaker is actually Richard Arwa, who I believe is speaking from Kenya. And the topic of his talk is bioethanol from Victoria Lakes Hyacinth. So yes, we can already see Victor on the screen. Victor, can you hear us?
Yes.
Oh, no, Richard, sorry.
You.
No, Richard, yes, sorry. Yeah. Over to you then.
Thank you very much, ladies and gentlemen. It is my privilege to share with you the journey of East Africa. My name is Richard Arwa, and I'm the CEO and the founder of Swiss Africa. So I'm requesting to have my slide on.
Sorry, he's requesting for the slide, for his slides.
Thank you very much. So we are all aware that the climate change impacts threaten the very existence of mankind if global concentration of greenhouse gases continue to build up. Continued dependency on fossil fuels means that carbon emission will be difficult to reverse. Conversely, developing countries still rely on fossil fuels as a source of domestic cooking and lighting energy. In Kenya, for example, biomass, that is wood fuel and charcoal, and kerosene provide the main sources of cooking and fuel for rural households. Now, high dependency on these fuels means that these households continue to emit substantial amount of CO2 that goes in the environment. Now, as East Africa, we look at a new technology which can provide a better cooking solutions for the households. Next slide. Next slide, please. So at East Africa, we make use of water hyacinth weeds in Lake Victoria, and water hyacinth is an invasive plant species which has covered nearly 3/4 of the surface of Lake Victoria and is doing a lot of ecological challenges to the people who live by the lakeshore, who depend on fisheries as a source of livelihood. So water has cost a lot of money in Victoria. It blocks fishermen from accessing the fish sites. It blocks the navigation routes for boats and ships. It has affected the tourism, and the livelihood of the people who depend on it is affected. Kenya has spent a lot of money to effort to eradicate the water hyacinth methods, including biological methods, mechanical methods, and chemical methods. All these methods have proved not to be successful, irrespective of huge amount of money spent on them. At the same time, the households living around the shores of Lake Victoria and at large in Kenya and in Africa still rely on biomass as a source of cooking fuel. So at East Africa, we've come up with a technology that converts the cellulose that is present in the stems of water hyacinth into clean and affordable energy. Next slide. So this is basically what we do. We harvest water hyacinth from the lake, and we can also substitute it with the crop residues, that is the stems of the sorghum, and we end up having clean energy which are used in specific clean cook stoves. And this gives us a healthy environment, and our cookers also cook in a clean environment, thereby avoiding many risks of health related to household air pollutions. Next slide. So basically, this is the technology that we use in our micro industry. We take the water hyacinth from the lakes and we put them in pre-fermenters. Within the pre-fermenters, we basically convert the cellulose in water hyacinth into simple sugars using the enzymes at controlled environment. Then we introduce the enzymes that convert the simple sugars into ethanol carbon 4 oxide. Then we use fractional distillation to separate ethanol from the crude matrix which is there. Then we take it through the purification system, which will help us to purify all organic compounds like aldehydes, ketones, and we get around 94% ethanol, which is stabilized and packed as a cooking fuel. Next slide. So these are our products, as you can see. This is the ethanol cookstoves that we use. Of course, we have sold around 1,800, and we end up having this type of ethanol cooking fuel. So this is marketing. We are distributing in the rural areas and semi-urban areas. And during COVID-19 also, we managed to compound some of our ethanol into alcohol hand sanitizers, which really helped to control the spread of COVID-19. Next slide. We target mainly the household living in the informal settlements in Kisumu, in Nairobi, and all informal settlements in Africa. And I want to say to a bigger extent, at 25%, we target the household livings in humanitarian setups. We are aware that even though the food supply and medical supply to humanitarian communities is well taken care of, the people living in refugee camps have a big problem in accessing clean cooking fuel. They mainly rely on kerosene and charcoal wood to cook their fuel, which sometimes they sell even their ratios of food to access. There is very limited policies in humanitarian setups to provide clean cooking fuel. So in this business model, we target mainly the humanitarian setups and the people living in urban settlement because they are used to purchasing the fuel. So shifting to a cleaner and affordable energy will be more easier than people living in the rural communities who mainly access the cooking fuel for free. Next slide. Our business model is simple. We harvest water hyacinth from the lake. We collect the crop residues from the field. We transport them to the workshop for processing, where we convert them into ethanol cooking fuel. We transport these ones to the retailers who extend the value to the consumers. Next slide. Perfect. These are our financial projections. The sales there, 2019, 2020, projected 2021 from the stoves, and also from the biofuel, as well as from the carbon credit facility. Next slide. This is our team. We have a team of young people. I'm Richard Arua. I'm the founder and the managing director. I have masters in chemistry, and Mr. Evans Okech is having degrees in sociology. And Madam Anne Odundo has degree in finance, and she's the director of finance. Mr. Erika Chuchien is the production manager. He has a degree in renewable energy and biotechnology, while Ms. Magdalene is also specialist in marketing. I want to say that so far up to date, we have sold a total of 1,800 stoves to low-income households, and we target to sell 30,000 stoves by 2025. Our current production capacity is 1,500 liters per day, and we have upscale production to 25,000 liters per day. It is my honor to say that with our technology, we can convert any cellulose into ethanol cooking fuel, any source of biomass. So the process is very renewable. We can use the grass, we can use the leaves of the plant, we can use the crop residues. Any cellulose we can convert into bioethanol fuel, making our process to be much renewable considering what is going on globally, particularly Russia and Ukraine, and the cost of fuel has really gone up. We are looking for the partners that can help us to upscale our production, and also who can help us to upscale our distribution to reach the bigger parts of Kenya and Africa at large. Thank you so much for listening. Once again, my name is Richard Arua. I welcome any question which may be there. Thank you.
Thank you, Richard. So we have time for maybe a few questions, one or two questions. If you could maybe bring up any questions on that came up on Slido. Okay, there's quite a few questions, but I think we'll only take two. What is the price of bioethanol produced in a plant of this size vis-a-vis conventional cooking oil on the local market? In other words, is this bioethanol competitive in cost-wise? So that's the question, Richard. Was that clear? Yeah. Richard, are you there?
That is clear. I'm saying I've been in Houston now. What costs $0.7 US, while currently the cost of kerosene, 1 liter of kerosene costs $1.4 US. So our fuel costs almost a half the cost of kerosene.
Okay. Okay, thank you. The second question is, how do you convince people to adopt the new type of cook stove? That is probably a general question that is of interest, I think, from the larger scale. Over to you, Richard.
Basically, as my As our first speaker presented, shifting to cleaner cooking energy needs a lot of behavior change, and we are partnered with the respective government agencies in this journey. There's a lot of advertisement. Clean Cooking Alliance of Kenya is doing a lot of work. But basically, we are doing a lot of marketing activities. We go to almost every shows, fairs, and exhibitions. We attend the public lectures like the university lectures. We do a lot of cooking demonstrations in the market to convince people because this is a new technology that they have not used before. So the behavior change is a combined responsibility for entrepreneurs that is East Africa, and we partner with government agencies in doing this. And we do a lot of marketing activities online and even physical meetings.
Thank you again, Richard. Unfortunately, there are several more questions, but unfortunately, time is up for the talk. Thank you, Richard. And now we will proceed to the next speaker, who is also joining us remotely. That will be Stefania Russo from the Ecovision Lab at ETH Zurich, or Swiss Federal Institute of Technology in Zurich. And the title of her talk is going to be Automated Large-Scale High-Carbon Stock Estimation from Space. I can already see Stefania on the screen. So over to you, Stefania.
Hello. Hello, everyone, and thank you for inviting me today. So I am Stefania Russo. I'm a postdoctoral researcher at ETH Zurich in the Ecovision Lab, and today I will show you a bit of the work that we do. But first, maybe I want to start by asking the audience a question. How much carbon do they think it is stored in tropical forests? And it's 10% or 30% or 80%. And then we will see the answer later. So start with the first slide. Yes. So as the world population grows, we know that the demand for food, for timber and other commodities continues to rise. And with it, of course, the demand for agricultural land. It is estimated, in fact, that almost a third of the global land has been transformed within the last 6 decades. And specifically, tropical forests receive particular attention because their transformation causes high ecological damage. In fact, forests play a critical role in regulating climate change. In fact, they absorb carbon from the atmosphere and they store it, acting as natural carbon sinks. Next slide, please. So recoverable carbon refers to carbon vaults that are the most effective stores, but are very difficult to restore. So recoverable carbon is a term that is used to identify areas that, if are lost, are extremely hard and impossible to recover. Tropical forests are one of the most important terrestrial carbon stocks, and among also the richest biodiversity ecosystems on land. Next slide. The high carbon stock approach, HCS, is a methodology which is nowadays implemented by different NGOs and companies and aims at conserving forests that are high carbon stocks by guiding the development in tropical countries in a more sustainable way. So the idea of this approach is that the landscape is categorized, as we see in the slide, into high carbon stock forest and degraded land. The former must be protected, while the latter can be considered for further economical development. So this strategy in total shall reduce the carbon emission and the ecological damage that is caused by land use changes. Next slide. So up until now, however, the forest mapping for HCS is extremely costly because the field mission that must be carried out to measure the forest structure parameters like canopy height and cover, from which the carbon density can be then derived, they're extremely costly. So we estimated a cost of about 200 to 500 euros per kilometer square, which means that mapping the entire land of Indonesia, Malaysia, and Philippines would amount to about 1.2 billion euros. So we need to definitely find another solution to to do HCS forest mapping. Next slide, please. So since March 2019, NASA's JEDI mission, which is a space-based laser scanner on board on the International Space Station, has been collected global measurements of vertical vegetation structure. So the idea is that the JEDI ladder sensor has been designed for the retrieval of biomass, and among the different forest structures variables that can be derived for such data, the most important prediction of biomass is canopy height. Next slide, please. Sentinel-2 is also a satellite mission. This is with the European Space Agency Copernicus program, consisting of 2 identical satellites which were launched in 2015 and 2017. Each satellite carries a multispectral instrument, which is designed specifically to capture vegetation characteristics. Next slide, please. So in our work at ETH Zurich, we use such large and especially important openly available datasets to retrieve forest parameters, avoiding, therefore, the costly field work. We do so by exploiting the potential of powerful computational costs like artificial intelligence and specifically deep learning, which take advantage of the opportunity given by the unprecedented amount of data that we are facing nowadays. In this work that I'm presenting today, we have proposed to use such data-driven approaches based on a state-of-the-art deep neural network that you see on the right-hand side of the slide that uses data from JEDI and Sentinel missions to estimate canopy height. So in the first step, both datasets are fused together, and then a deep convolutional network is trained to estimate canopy height. In a second step of this approach, the carbon density map is regressed from the canopy height map, which allows us to produce a high carbon stock map. Next slide. So you can see here that we computed maps for the beginning of 2021, which cover Indonesia, Malaysia, and Philippines. And the performance of the model estimated are about, so the model performs with an error of about 4.6 meters, which is pretty low considering that the maximum vegetation height is about 50 meters, which is actually where the model saturates. And the model slightly underperform on very low canopy height. Next slide. So based on the canopy top height that we saw before, then the carbon density is regressed to derive the HCS classification that we saw before. So the landscape is divided into the high density and the lower density map. So HCS, and then we have the OLS, open land and scrub. And in terms of binary accuracy, in this case, we have reached an accuracy of about 86%. Hoping that this can guide economical development in different countries while preserving forests with high carbon stock. Next slide. At our research at ETH Lab, we are a team of PhD students, scientists, postdocs, and professors, which also work on biodiversity estimation, flood height estimation from social media images, and oil palm mapping, and other projects that aim at tackling biodiversity and climate change. Next slide, please. Then I would like to end this talk by saying that I believe we should always think in perspective. In fact, as we are now facing the economical fallouts of COVID-19, we should not also lose focus and forget the tsunamis of climate change and biodiversity collapse that are behind it. These are crises of our own mankind, and if we do not act with urgency, then we will pay the price for this for the next centuries. And with this, I finish my talk, and maybe we can see the results of the poll. It's 30%, so almost close. I mean, it was actually made on purpose. I believe that 8% seems a very large number, but 30 it is also a lot of forests in very northern countries. They also store a lot of carbon, but we are not. Or still, we are interested in saving them, but they are not used now for economical development, since they are very hard to use for growing any type of food or for land use.
Thank you, Stefania. So we still have time for a few questions. If maybe you could bring up the questions from Slido. The first question is, what are the concrete measures that can be taken once the carbon biomass has been assessed, and by whom? Yeah. Over to you, Stefania.
It's a very interesting question. So this is part of what we do in terms of our research at university, but then what we aim to do is actually implementing those changes, and for that we need policymakers. So we need the models that we developed, for example, in this case, deep learning models, to be trustworthy enough so that policymakers can actually implement those changes and therefore implement changes for the land use based on these results. It's not an easy approach.
Thank you. And the second question is, can the model discriminate a diverse old forest from a dense monoculture of eucalyptus, for example? And then, I don't know what SOC stands for. The SOC accrual would be very divergent, right? Over to you, Stephanie.
If I understood the question correctly, so it's about how much the model can diversify the type of forests. And so this model that I specifically presented today, it cannot, because it has been trained specifically only to estimate the height of the forest. However, we are also working on other projects which, for example, try to estimate cocoa plantations. So as long as the deep learning model is trained on seeing during training a specific set of data representing what we want to achieve, then my answer is yes, it can be done. With how difficult it is, that's another story.
Thank you very much, Stefania. There are still further questions, but we are out of time for this particular talk. Thank you, Stefania.
So Thank you.
Now, for our last but not least speaker for this session, that will be Bruno Joachim, and he will be speaking to us about an initiative on the Climate Action Accelerator. Over to you, Bruno.
Bruno Joachim. I'm the director of the Climate Action Accelerator. But I'm also a former humanitarian. I was the director of Médecins Sans Frontières in Switzerland and worked many years in the field too. So I'm basically the non-tech person in this group, and I'll be speaking to you from a different angle, mainly presenting you the lessons we've learned with an experimental roadmap at the level of an aid organization, trying to address the question, how can we basically decarbonize aid concretely? I'd like to start just with a few points on what the scientists that were present yesterday at the IC Forum told us, whether it's Johan Rockström or the Swiss, I think it was the chief scientist. You know, what they said is basically we're collectively taking a big gamble. We have if we want to have a 50% chance of maintaining global heating under 2 degrees, we have to go to zero emissions, net emissions by 2050. If we want a 66% chance of making it, it has to be by 2040. And what all scientists are asking us to do is at every levels of society, whether it's states, organizations, people, is to radically cut our emissions in the next decade. And they're asking us to do this by 50% by 2030. And this is without compensation. We're talking about absolute reduction pathways. So what we're trying to address with this question, maybe we'll go to the questions to the public first. So before I enter into the subject, I've just a question for you to think about is how much do you think technology actually contributes to decarbonization roadmap for an aid organization? So do you think it's 90%, 60, 30, 10%? So please think about it and we'll see at the end. Next, so the Climate Action Accelerator, what we're focused on is about the how to do it. It's a non-for-profit initiative based in Geneva. It's mobilizing aid organizations, but also health organizations. And we have basically 3 pillars. It's how to operationalize climate action, basically how to turn intentions into practical results. It's how to create a domino effect with a critical mass of organizations expanding to actually make a sector tip. And third, it's about creating a community of practice whereby the know-how, the solutions is made available for all to uptake and accessible for free. So we worked last year with the International Medical Alliance, which is based in Dakar, which is, I would say, a mid-size NGO, about 60 million euros budget. Can we put the next, please? And they're active in sub-Saharan Africa, mainly on emergency medical aid. And when we look at their footprint, I mean, first, you should know that aid organizations do have a significant footprint, like every other organization in society. So for an organization like this, it's about 13,000 tons per year in 2019, pre-COVID. And it's actually still increasing because they're developing their activities. Now, when we look at concretely what they have to address if they want to reduce their footprint, it's actually the footprint is very concentrated. What you have in yellow is basically the procurement of goods and services. And within the procurement of goods and services, it's basically medical supplies, almost 2/3, nutritional supplies. So what we have here is basically, it's the extraction of resources, the fabrication of products, and the transport of products to make it available. So it's the supply chain. For many organizations, this supply chain aspect is actually 60% more to 2/3 of the footprint of an organization. Then what you have in green is transport. And in transport, it's basically a mix of freight, how you transport goods, mainly by air, and you have also transport of people, where you have both road transport and air transport. This makes the second, I would say, significant contribution to emissions. And finally, what you have is what we call is buildings, and mainly energy in buildings. So it's, for an aid organizations, it's a lot about generators, it's about climatization, etc. So curbing down basic emissions of an aid organization is addressing each one of these key components. And what we found out is that you actually have 5 solutions that are predominant in making the footprint of aid organizations much lower than they are today. And this is a trajectory. It's a trajectory of emissions. So the black line is actually the evolution of CO2 equivalent emissions for an aid organization. So you see actually that it's still going up from 2019 to 20. And I think it's a picture of our society. If we continue as business as usual, our emissions will continue to increase despite the climate crisis. So what you have on the top is basically the business as usual scenario. And then you have the different levers that can be used to actually try to lower these emissions to the level that actually is requested by the scientific community, which is at least half by 2030. And the interesting part is that you have 5 solutions that actually can make a big, big difference. The first one is procurement criteria in your purchase of goods and services. So this is key. Technology here plays a part because it's about also product substitution, but it's also about, I would say, negotiation with suppliers on making the footprint of their products actually transparent and taking it into account when making choices. It's a lot about transport, but it's not just about flights. Flights is important. It's also about fuel efficiency of vehicles. It's also about shifting radically from air freight to maritime freight, even in emergency situations, or really reducing it to the strict necessary. And finally, it's about deployment of renewable energy in basically every intervention of humanitarian organizations. This makes up more than 85% of the decarbonization roadmap of this organization. Okay, it doesn't mean that. So we're really. I mean, this is a preliminary roadmap. At this stage, we have 15 more aid organizations that have joined the initiative. We're currently working with ICRC, with Médecins Sans Frontières, with the Terre des Hommes movement to establish the plans of action and look at what are the levers that would allow to actually do that in practice, but while obviously comforting their mission, because of obviously assistance to vulnerable populations is needed. The needs are going to grow, as it was said at the beginning. So the whole question is how to do it in a way which minimizes the footprint. I think what's maybe to now conclude on our ambition. Our ambition is with these experimental roadmaps and with extracting the lessons of different organizations is how to amplify, how to basically produce a generic roadmap for a sector, which is here the international aid sector, and make sure policies of funding and organizational policies are actually adapted to, I would say, respond to the absolute request of the scientific community to get things under control. And I think in many ways, every sector in society needs to go through this process. This is, here we're talking about aid, we're talking about health, but it would be the case for the education and research sector, for the tech sector, for many others. And I think maybe to conclude here, action is now more needed than anything. We are in an emergency situation already. It's very clear there's been many warnings to humanity, and it's time for plans of action to be unrolled and to focus on how to do it. And I'll stop there. You can have, if you're interested, you can have a look on our website. The roadmap is actually accessible to all, or it can be sent to those interested later. Maybe to come back to the question.
Yes.
So the answer, the true answer is I don't know. I don't know what is the answer. But from the experience we have with the International Medical Alliance, it seems to be probably around 30% only that is linked to technological solutions. And where it matters is mainly on the energy side, on the renewable energy side, and some product substitutions which are necessary. But what we learned with this roadmap is that the other organizational levers are absolutely, first they're considerable in terms of margin of maneuver, and they need to be activated in priority. So organizational policies, behaviors, processes, procurement policies, travel policies, criteria for purchasing vehicles, etc. All this is simply within the hands of everybody, We're talking about mature technologies that are already available. And I think, you know, if we were to rely too much on technologies that are not mature today for acting, we would be adding a second gamble on top of the first gamble I mentioned at the beginning, which is only a 50% chance to keep the global heating below 2 degrees. That's what the scientific community is telling us. Thank you.
Yeah. Thank you, Bruno. Maybe we could have the questions on Slido. We only have time for one question, so we'll take the first one. Which technologies do you see as the future of sustainable transport or travel industry? Is it the same technologies for road, air, and sea transport?
Yeah. So what I can share is our analysis of the problem as we basically went through it last year. There are no sustainable alternatives to air travel for the moment. Maybe it will come. Maybe in the 2030s, 2040s, you'll have other solutions. What we have today is planes that maybe are more fuel efficient than others, etc., etc. But the biggest lever on actually reduction of air travel is basically transportation policies within organizations. There's been an explosion of flights over the 15 last years, really an explosion. In many organizations, flights have been multiplied by 3 or 4. There were humanitarian operations before. they actually functioned, etc. So the question is how to go back to more reasonable use of transportation, but it's also about localization of expertise, localization of procurement, and it goes within the agenda of the aid community also. The more you go for certain regionalization and localization, the more you put under control air travel. There are other levers, but technological solutions for air travel are actually very limited at this stage, and they may come, but in 20 years it's extremely late versus the emergency. On road travel, it's probably about today mainly, and notably in sub-Saharan Africa, it's mainly about fuel efficiency of vehicles, so the weight of vehicles, the type of engine, etc. And probably later there will be the possibility to move towards maybe electric alternatives, but not before probably at least 10 years in sub-Saharan Africa. So it's not actionable right now.
Well, we're out of time. Thank you very much for that interesting talk. This now concludes the first session, or the first part of this session, and we will now go to the second part, which will be a panel discussion, and I will now hand over to my colleague here, Churchill, to oversee this, moderate this part. Thank you.
Thank you, Solly, and thank you so much to all the everyone who's pitched. Really interesting insights. And before we go into the next session, we wanted to get some feedback from you through a Slido or word cloud. And so we wanted you to answer the question: what word comes to mind when you think of the role of technology in helping in the alignment of international cooperation and climate action? So based on the presentations and also your own experience, what word comes to mind when you think of the role of technology in helping with the alignment of international cooperation with climate action? And in the meantime, I'd like to ask the panelists to come forward for the panel discussion. Right. Essential seems to be the word that's coming up a lot. Essential information, governance, enabler financing. All right. Really, really interesting insights. And so we can already see that technology and technological change is creating significant impacts when we look at climate action and climate action in the context of mitigation and adaptation, but also in the context of international cooperation. And so for the next 40 minutes, we're going to engage with the panelists to help us understand this interaction between international cooperation and aligning it with climate action and where technology comes into the mix. And so you've already met some of the presenters, and so I will ask the panelists who've just joined and did not introduce themselves to briefly introduce themselves. I'll start with Veronique from my far left.
Hello, sorry, I'm Veronique Michaud. I'm a professor at EPFL. I'm a specialist in material science, but I've been involved in quite a lot of projects with the international cooperation.
Thanks. Yael?
Hi, my name is Yael Borowski. I'm a senior scientist at the Development Economics Group at ETH Zurich, and also an editor of the ETH Energy blog. Shameless plug, if you want to know more about it, you can check it out on Twitter at ETH Energy blog. Churchill also is an editor. And my research actually focuses predominantly on access to infrastructure in informal settlements, as well as electricity access.
All right, thank you so much. So I'll begin with Bruno. Thank you so much for already giving us some insights into sort of how we need to start thinking about this alignment. And so based on your experience, what are some key considerations that we need to account for when we think of the role that technology can or could play in aligning international cooperation with climate action?
Well, I think, considering this is an emergency, I think the priority should be the deployment of mature technology. So obviously innovation has a strong role to play for what happens after 2030, 2040, and it's essential to actually prepare this. Mm-hmm. But the transformation needed in this current decade is so deep that you need to count on mature technologies to actually be successful. So that's, I would say, and this includes also low tech. So it's high tech, but it's also low tech. And it includes not only technological products, but actually, I would say human technology, which is what are the processes within organizations that allow to lead this transformation. Alongside products, what you have is the need for investment in human capacity. You need to have, again, supply chain processes that are reviewed. You need to invest in, I would say, localization much more heavily. Mm-hmm. And then for when it comes to funding policies, you need funders, and here you go back to the role of states, notably, need to create an environment and a facilitating funding mechanism whereby you can shift expenses from one area to the other. What we saw is that at the level of an organization, and I wouldn't generalize to every organization, but we saw that you can have significant savings on transport, for example, that actually allow to invest in other areas such as renewable energy or additional costs in procurement linked to criteria. So making this facilitating funding environment is going to be key to actually make scale up.
Okay, thanks. So it goes beyond just the technology, and there are other aspects that you have to think about. How about you, Veronique? When we think about sort of again aligning international cooperation with climate action, are there specific sectors and specific technologies that can sort of play a role in this context? Maybe give us a bit of a big picture and some sectors that you see that have this potential for impact, in the context of maybe mature technologies or technologies that are getting close to that point.
Yeah, it's a it's a vast question, but I think we have to look a bit at where we can act the most efficiently, and really look at the big picture indeed. And yeah, I think if you look at the main sectors where there is something to do, it's really, and we saw it also in some of the presentation in everything that is related to energy consumption and production, so fuel, charcoal, wood, fire, and trying to find ways to develop and to help implement cleaner energy situations. And this needs technological, of course, developments, but they could be also very mature technology, like solar panels or hydropower. Or, but I think what needs to be taken into account is the fact that this should not be just transplanted, but they have to be made in a way that they really coexist with the local ecosystem, and that they are really made also taking into account all the local aspect and the different climate, different needs, different infrastructure, different training of people, and so on. So that's one aspect. So another one we saw is really food production, agriculture, and for sure it's also a big, I think, a CO2 impactor. Not only because we need deforestation to make more agriculture, but also maybe because some of the agricultural waste is burnt. And so there are lots of actions that are taken in trying to use the agricultural waste and transform it and valorize it instead of burning or trying to let it decay into products. I mean, we're working in introducing it into composites because that's my field, but that's one example of trying to make more sustainable products or replacing partially plastics using waste. So that's actually true also in our developed countries. But there are lots of potential. We work with Colombia, for example. They are a huge agricultural country, and they have a lot of waste that they don't know what to do with, and they don't valorize it at all. And so that's another example. And then, of course, also in the agriculture, there might be modern techniques like using drones or using surveillance to be able to improve the way we do the water, the irrigation of the land and so on. So try to make it also more power efficient as we can. But then there are many other sectors that we discussed, that transport and building, and there I think again we have to think about ways to minimize the transport. Maybe using better communication systems might be a way. Maybe using drones, for example. There are projects with the Central Tech, I know, where the idea was to use drones for transport of medical goods, for example. And that could be a way to be fast and to avoid having to use trucks and so on, and maybe use some more efficient and direct lines instead of having to do many kilometers. So there are many ideas, but I think every time my feeling is that we have to be careful about having good ideas and trying to implement them. You really have to look at the local impact, the overall impact that this can have, the logistics, the situation, to be as efficient as possible. And maybe not always looking at super new techniques, but some mature techniques and finding new ways to implement them or combine them.
Right, thanks for that. I think this point about local impact and doing logistics efficiently has some like early low-hanging fruits almost that we could address. Yeah. And then this kind of segues really nicely into the next question, which is thinking about context and to what extent context is important. So I'm relaying this to you, Fred, and Yael as well. When we look at context and we think about, again, aligning international cooperation with climate change, to what extent should our interventions be different, if at all they should be?
Yes, thank you for the question. I think the contexts are very different. In developed countries, we have an existing infrastructure that is robust and that is used since many decades. And in developing ones, there is a very growing economy with new cities that are being created, and this is an opportunity for many big companies. So they are trying to develop products that are commercialized there. They are trying to really capture the growing market, But I think there's still that problem of technology adaptation to the local context, because sometimes the habits are not the same. The culture also can impact on the technologies that are developed. For us, for example, I showed the prototype of the hydrogen stove that we manufacture in Switzerland. And at a certain point, we needed to decide to send a designer, which is an expert in human-centered design, to go to Cameroon to discuss with people, to cook with them, so see how they cook, how they go to collect the fuel, what's the behavior, what are their priorities, and when they buy the stove, what do they care about. And after the first survey already, it came out that the product should be really adapted, even if the technology is the same. Inside, the core technology is still catalytic combustion of hydrogen, producing only water, but the design completely changed in terms of the power, in terms of the definition and the robustness of the stove that we are supposed to develop. And except that, here there's also the problem of the cost. So we also need to adapt the technology to the capacity of the people to buy, to invest in the technologies, because sometimes the main problem is the investment at the beginning, so the capital expenditure. So from our surveys, for example, it came out that charcoal in Cameroon, charcoal is more expensive than gas, than natural gas. But why do people use charcoal? It's so productive for them and for environment. It's because they don't have money to invest in a gas stove. So that means that there's still also that big problem of how to really adapt a solution, not only the technology itself, that should be a low-cost technology, but also how to finance that. So to consider a solution as renting the product, the stove, and only commercialized technology, so people have time to pay progressively for the fuel only.
So like alternative business models almost to
Yes,
deploying the
exactly.
technology.
Yeah.
Okay, thanks. And how about you, Yael?
Yeah, I think I can actually, only agree with a lot of what Freddie said, that, I think context matters. I think anyone who works in international cooperation realizes how important that is. And I think that one of the issues is that when we focus so much, though, on least cost technology, is that we often then very much forget many of the other factors that are really important, as you mentioned, culture, habits, things that people just really prefer, or ways of doing things, or ways of paying for things. And I think, as international cooperation turns now to thinking about climate action, we maybe run the risk of getting a little bit of that kind of horse blinders approach, where the priority goes from least cost to climate-friendly, without actually really prioritizing first and foremost people's needs, the problem people face, and then what's the solution for that problem, then figuring out how can we do that either cheaply, in the case of least cost technologies, or cleanly, or in a climate-friendly way. So I think, thinking first and foremost about what is the problem we're really trying to solve, and then building in, either the least cost approach or the most affordable approach, or something that's clean and environmentally friendly that won't have long-term impacts on the environment.
So thanks, Fred and Yael. I think one of the things that I'm taking from what you're both saying is that it actually is very, very complex, right? And it's sort of having, now how do you kind of find a balance between these three different aspects? And it then kind of raises this question, which was also part of our title, which is this conflictual relationship. And I'm posing this question to Gabriela, which is when you kind of look at international cooperation and you look at climate action, and we sort of bring in this idea of economic development, and when we kind of think about it, do you see any kind of potential conflicts between these objectives, and can we possibly address some of these shortcomings using technology?
I probably don't see the conflict between the technology and the solutions. I see it with a little bit in a way as we look at the solution still. We talked about context, we talked about the situations, but we still do not take them really serious and into consideration, because sometimes we come with solutions that probably would have been thought of by the people that we try to help still, but because of lacking education or finance, they cannot fulfill it. So we come then from somewhere with a solution, or even tell them that we bring the solution, and we undermine the local activities. So, I mean, I'm representing a person that has come from the global south, but due to education lacks, to the global north, and developed the idea he had with the technologies, and will bring it back to the south. So, I mean, probably we should think on how can we bring the development of technologies to the south, and not the technologies.
Okay, okay. And any more insights into this? I'll leave it to maybe Fred and Yael to give some insights if you have any.
Yes, I completely agree with what said Gabriela, that I think at this point, technology transfer itself is even more important than technology, because if I take the example of solar energy, for example, it's already competitive in many developing countries in the West compared to the other technologies that are used. But even if here is considered a mature technology, there many people are disappointed by solar technologies, because they use wrong components that are not properly designed, and also the maintenance and how to really use them is not they don't really rely on the proper approaches, and the knowledge and know-how about how to manufacture and operate the systems, they don't have it. So that's the reason why some people will invest and in solar systems that are not efficiently designed, and after, when they will complain, the people will say that no, solar technology is not ready at all. But for people who do it properly, they really understand that, for example, in Central Africa, after 3 to 7 years, you have a return on investment.
Okay. Any insights, Yael?
No, I think they covered.
Okay. I think that just to allow for some time for maybe questions from Slido as well, I'll pose a question to Veronique, Bruno, and Gabrielle, which is, are there like specific key actors who you see as facilitators in enabling this sort of alignment when we kind of look at international cooperation, climate action, and sort of bringing technology into the mix? And are there any concrete examples that you have, or things that you think need to be thought about in enabling this alignment? I'll start with Veronique.
An easy answer from my side, being at the university, is that universities can be key actors for sure. And on two sides, I think, and this comes back to some of the points that were mentioned, we need to do nice research projects and develop good, new technologies that are adapted for sure. But we also need to teach our students to not only look for the beautiful technological solution, but that there is a market, there are customers, there are acceptance. And we're really trying to make an evolution in the way we teach our students in at least the technical fields, so that they have some glimpse of the fact that it's not the most beautiful technological solution that will be adopted, and that they have to really already take into account the context, the customers, their needs, and maybe they have to make their solution evolve so that it fits and it will be accepted.
Yeah.
And I think, so that's what we're trying to do. There are lots of programs. Another program is also to, of course, create collaborations with between institutions. That's what, at least at EPFL, they have now this program with Africa, that, where it's not that we bring African students at EPFL and teach them, which of course we can do, we've done, but it's really to have a co-supervision of students in Africa by EPFL professors, and really help them to also maybe give them more opportunities to access different tools, but also create this kind of cultural exchange, I say, or technical cultural exchange in the way we approach the science, and letting them develop their own methods also that are adapted. So there's a lot to do, for sure.
Right, so collaborations and also instilling these new ways of thinking about these solutions.
Yeah, and tapping into the potential.
Yep.
that is there, that is everywhere, in particular with the young students that we have.
All right, thanks. And how about you, Bruno? Any insights that come to mind?
It's a difficult question, of course, but I'd like to say a word about the importance of organizations as consumers and the weight of their procurement. I mean, we talk a lot about manufacturing, about agriculture, which for very good reasons, because they are producers. But the demand side is about procurement, and big organizations have a procurement power where they can actually, they can signal a shift of the demand from certain products to others. And I'd like to take the example of in the health sector of the National Health Service in the UK, which is going through a real transformative process with a net zero strategy. They're basically telling suppliers that they have a few years to actually comply with disclosure of information on all their products, on carbon footprint. And if they do not adopt, net zero plans for their own companies within a certain time frame, they will be out of the picture, you see? And why this is important, because it addresses leadership and it makes plans compulsory. And I think it's a very powerful tool, very powerful. And if donors, states, organizations through their procurement policies align on this, it can have a real impact.
Thanks.
Can I add to this question?
Yeah.
Maybe I just wanted to add, I think one thing that's important to realize is that there's a role for actors at every level of this problem, right? Like from, multilateral development banks all the way down to local NGOs or researchers doing very localized solutions. And I think, this doesn't need to, it doesn't need to be constructed as a conflict between poverty alleviation and climate mitigation or even adaptation. I think there are actually really important opportunities at every level to kind of find ways to develop solutions that actually lead to economic growth or lead to economic development, alleviate poverty, but also don't do worse. I think there's been, in some of the other sessions, there was kind of this question that came up that got averted, which was, how come the multilateral development banks, like the World Bank and also many richer countries are saying they're not going to invest any more in natural gas. And, I think this comes a bit from a fear of path dependence, of concern that, many countries in Africa will suddenly become major fossil fuel users and major emitters in the next 20 to 30 years. But actually, many countries in Africa have already major plans to use mature technologies, deploy renewables, and then gas actually plays a really important role in supporting these kind of very climate mitigating long-term energy plans. So I think there's a really important role there for thinking, where can we achieve both goals? And I think, the other part, and this kind of speaks a little bit to the point that was made very early on in the session by, I think, Mr. Bessler, this idea that, when we think about climate resilience, actually richer countries are in a much better position to respond to, whether you call them natural disasters or other types of disasters. Richer countries are in a much better position to respond to those than poorer countries. And so making countries richer so that they can respond to, heat or, drought or flood or something like that is important. And I think one, really good example of that is in cooling. That hasn't come up as a technology today, but I think in cooling this is a really important opportunity where there's actors at every level, including consumers who, most of the air conditioners in the world are not in the hottest countries. And so actually this is a really important situation where you can have technology innovation, not necessarily technology transfer, but policy environment that can allow for more efficient air conditioners, and that can really make a big difference in preventing some of the worst impacts that we're expecting from climate change on affecting people, maybe preventing some of the humanitarian crisis by allowing people to more efficiently and cleanly cool their homes without suffering from heat. So I think all along the kind of like actors in international cooperation process, you have the opportunity for people to find these solutions rather than seeing it as kind of this, we need marriage
Like a
counseling
tension, yeah,
kind
okay.
of problem.
Okay, thanks. So it's sort of like levels and like allocating responsibility. And how about you, Gabriela? Are there any actors or any actors that come to mind and any actions that
I think
you
all
propose?
has been said somehow, and in regards of the time and the questions that might come from the audience, as it is a working session, I would rather give the word to
All
the
right,
audience.
to the audience. Okay. So we'll move on to questions from the audience. Is it possible to share the Slido? All right. So the first question, I think I'll kind of just ask it, and then whoever is able to answer can just raise your hand. Would you rather invest in technologies or in policies and strategies to increase environmental absorptive capacities, reduce deforestation, etc.?
Shall I?
Yeah,
I
you can go
think
ahead.
even though I'm from the practical side, I think policies are more powerful if they're really also executed.
Okay. Any other? Okay.
Yes.
That's just okay.
Yeah, I completely agree. I've been working in technology for more than 10 years. And at a certain point, when we start really to implement the technology and develop markets, we realize that we really need policies that define the rules, the proper rules, in order to encourage those innovative solutions. And also, at the same time, we really need roadmaps. So roadmaps that clearly define where we are targeting to be in 20 or 30 years, and that really allows to implement back the technologies that can fit to those policies and roadmaps.
Okay. The next one, is there a risk that rich countries use international cooperation to distract from their responsibility at home regarding climate action? Anyone?
Sure, I can take that one. Yeah, I do think that's actually a risk. I do think that, you see many countries really stalling on their efforts to meet climate targets, or in the US, where I'm from, stalling on most every front to enact anything that even smells like a climate policy. And so I do think that that's a real risk. It's a bit of a cynical perspective, but it's also, I think it's partially the truth, is that, this is where they can take action. It's easy to say, well, not easy, but it's possible to say, okay, we're not going to invest in these technologies in other countries, but they continue to invest in those technologies and the use of those types of energy sources in their own countries. And so I do think that it's a bit of trying to play both sides, unfortunately.
Okay. Anyone else going? Okay, we'll take one more question. How can, did someone raise? No? Oh, okay, go ahead. Oh, so you can see it, cool. Yeah, go ahead, Gabriela.
Okay, I mean, I think that we are talking about climate action, but we undermine a little bit that big infrastructure finance will be needed first in the global south in order to make things accessible. Poverty can be reduced by making access to markets, access to energy, and access to finance possible, and the first to demand a big infrastructure move. So actually, yes, first infrastructure, and these infrastructures have also to be climate smart.
Climate smart infrastructure. Thank you so much for all the insights that you've shared. I think my biggest takeaway is that this is a really complex challenge. It's more than just technological interventions, and there's some things that we can actually already do in addressing some of these issues. So thank you to everyone for their participation in this group session. And so there are 3 opportunities for you to share your own knowledge and voice. So what did you find as the most impactful idea, concept, or solution that you learned about? You can do this by visiting the knowledge wall, where you can reflect on and share some of your key takeaways from the session and provide your thoughts on this. Provide your thoughts about what key stakeholders should proactively do from the start, in terms of continuation and in terms of change. When we look at this conversation, the QR code has been shared on the screen. Second, you can go to the IC Forum website, where you can share your innovative ideas, which you feel have and are contributing to the achievement of SDGs. And then last but not least, you have an opportunity to, for those who are physically present, you have an opportunity to engage with your peers and share insights. Thank you, and enjoy the rest of your day.